Hello everyone, welcome to my channel. So today I will be teaching how to get the reverse of the given integer. So when we have a 32-bit integer x, so let's assume the integer is x 1 2 3. This is the given number, so we have to find out the reverse of the given number, which means 3 to 1. So we have to obtain 3 to 1 from 1 to 3, and there are some other conditions that are given as well, such as while reversing, if the value goes outside the range as minus 2 to the power 31 to 2 to the power 31 minus 1, then it has to return 0. So this is the condition, and let's start with this. So when we have the given number as 1 2 3, in the output we want the number, the last digit as the first digit. So we need to get the last digit first. So I will assume it as the digit, and let's say I want to write the basic algorithm on how it works. So let's assume the reverse number is 0, the number that we want. So this is the given number, and this is the output that we want, which means the reverse number. And let us assume the reverse number as 0, and first we need to find out the last digit of the given number. So the last digit of the given number can be obtained by when the given number is divided by 10, and the last digit is always the remainder. So when x is divided by 10, this modulo means it always gives the remainder when the given number is divided by the certain number. So in this case, when 1 2 3 is divided by 10, the remainder would become 3. So in this way we get the final digit. So we have the digit as 3, and now let's change the reverse part as reverse into 10 plus given digit. Let's try this. So earlier we have the reverse as 0 multiplied by 10 would be 0, and let's write it here. 0 multiplied by 10 is 0, plus digit, we have digit as 3 in this case. So in the reverse we have 3 for now. Let's not write this, but just we have reverse as 3, and now the number has to be changed because we want the other digit as 2. So x can be written as x divided by 10. So when x is divided by 10, the remainder will be like, not the remainder but the quotient will be 12, and here 3 is the remainder. So these are the 3 steps. So I can show you how it works. So for the first time the reverse is 0, and digit we will get the digit as x modulo 10, which means we will have 3 as the digit, and reverse would be, reverse is earlier 0 multiplied by 10 is 0, plus digit is 3. We have reverse as 3, and x will be changed to x divided by 10, which means 12. In the second case, let's say x is already 12. So when x is divided by 10, we will have remainder as how much? 2 will be the remainder. Now what will be the reverse? Reverse would be reverse multiplied by 10, where we have 3 as the reverse. 3 multiplied by 10 would be 30, plus digit, we have 2 as the digit here, so it will be 32. Reverse is 32, and now x is changed to how much? X divided by 10, which means we have 1 as x now. In the third round, let's see how much will be the digit. Okay, again x modulo 10, which means now x is 1 modulo 10, we will have remainder as 1, and now reverse is already 32 multiplied by 10 plus digit is 1, which means 32 into 10 is 320 plus 1 equal to 321, and now x equal to 0. So in this case we have the input as x 1 2 3, and finally we have the reverse number as 3 to 1, since we had assumed that the reverse would contain the final reverse output. Like here initially it was 0, and now at the end reverse would be 3 to 1. So and this is how we find the reverse of the number, and these three are the major steps that are used to obtain the reverse of the number. So we will first get the last digit of the given number by obtaining the remainder. Again we will get the reverse number step by step. This is how we change the reverse in each step, and at the end we have to change the given number x as well. And here there is the other condition as well, which says if x equal to minus 21, then the reverse number should be equal to minus 12. So in this case we have to take care of the sign as well. So I will just write the code for this one, and it will be clear in the code. Now I'll be writing the code implementation for this one. So as we discussed, we can suppose the reverse number to be 0 initially, and we need to find the sign of the given number, that is x. So how can we find the sign? Which means if the number is less than 0, the sign will be minus, otherwise the sign will be plus. So that's the way we can find the sign. So minus 1 if x is less than 0, otherwise the sign should be plus 1. So we can find x as x into sign. So this is the sign. Now we need to find the logic, where the logic would be we want to go each step until the given number is less than 0, while x is less than while x is greater than 0. Until x is greater than 0, we need to just find the remainder and the quotient of the given number. So we want to find the last digit. So I already mentioned that the last digit of the number can be obtained by the remainder when the number is divisible by 10. So x modulo 10 would give the last digit. Now the reverse can be obtained as reverse multiplied by 10 plus digit. So I have already shown how this part is implemented by showing the example, and later the x has to be changed as this. So there is one condition which says if the value goes out of this part, which means if reverse is less than minus 2 multiplied to the power 31, or reverse is greater than 2 to the power 31 minus 1, we need to return 0, otherwise return sign into reverse. We need to take care of the sign as well, and if the given number was initially negative, then we need to return the negative number as well. Let's run the code. It's being run, and let's see. Yeah, the first case was 1 to 3, we got the output as 3 to 1, expected was 3 to 1. The second case was minus 1 to 3, expected was minus 3 to 1, we got minus 3 to 1. And the third case was 120, output is 21, and expected was 21 as well. So thank you so much and happy coding.